We're going to take a look at a few examples here just to get us going here, and then we'll work on our own for a while. Well, you can see I have our first problem up here. Cotangent squared minus 1 over cotangent squared plus 1 is going to equal cosecant squared minus secant squared over cosecant squared plus secant squared. Side note here, very likely one like this might be on the test. So let's start here, and we can pick either side to work on. I'm going to start to work on the left-hand side. I'm going to change cotangent squared to be cosine squared over sine squared. I'll leave the 1 for right now. And I'll change the cotangent squared in the denominator also to be cosine squared over sine squared plus 1. By now we've seen several common denominators. So here I have a fraction over a fraction. So this needs to be a single fraction and this needs to be a single fraction before we can multiply by the reciprocal. So I'm going to go through the top one, and our common denominator between those two terms would be sine squared, and that would give me cosine squared minus sine squared as my numerator. Noting this already has a denominator of sine squared, this does not have that denominator, so we multiply it by sine squared to get here. And we'll repeat the process with these two terms. My common denominator here would also be sine squared, and that would make my numerator cosine squared plus sine squared. Now you may notice that cosine squared plus sine squared is 1, a Pythagorean identity, but you'll also notice that we want to have an addition sign here. So as I go to multiply by the reciprocal, I want to keep that addition sign, so I'm not going to change it to its identity. So as I just mentioned, multiplying by the reciprocal, I have cosine squared minus sine squared over sine squared multiplied by the reciprocal of this fraction. We're dividing fractions, so we multiply by the reciprocal, and that would give me sine squared over cosine squared plus sine squared. So I'm hoping the obvious note here is that the sine squareds would cancel, and I'd be left with cosine squared minus sine squared. And again, I did not change the bottom to my Pythagorean identity because I wanted to have that addition sign. So I have cosine squared plus sine squared in my denominator. Obviously very close to this, but not quite the same thing. But cosines can be changed to secants, and sines can be changed to cosecants. So we'll go ahead and make that switch as our next step. Cosine squared is 1 over secant squared. Sine squared is 1 over cosecant squared. And we'll repeat the process with our two terms down here. Cosine squared is 1 over secant squared plus sine squared is 1 over cosecant squared. So now you can see we have a similar situation to what we had back here. We have two separate fractions. We want to combine those into one so we can multiply by the reciprocal. So my common denominator now is secant squared times cosecant squared. Both of these terms make up our common denominator, which means my numerator for this first fraction would be cosecant squared, and my numerator for my second fraction will be secant squared. You can hopefully notice how we're making progress here, trying to get to cosecant squared minus secant squared, so I have that here. Now I'll repeat the process with these two terms. I also have a common denominator here of secant squared times cosecant squared, which would make my first numerator a cosecant squared, and my second numerator a secant squared with a plus sign in between. I have one fraction divided by another, and when we divide fractions we multiply by the reciprocal. So I'll go ahead and show that down here. Cosecant squared minus secant squared over secant squared times cosecant squared multiplied by the reciprocal of this fraction here. So I flip that over and I have secant squared. I can get this pen to work right. Secant squared times cosecant squared over cosecant squared plus secant squared. And you probably recognize it already, but when we multiply by reciprocal, the secant squareds will cancel, the cosecant squareds will cancel, and we're left with our answer, which is cosecant squared minus secant squared over cosecant squared plus secant squared. Okay, so that's a fairly long problem because we had to do common denominators on two different occasions. But it's a step-by-step process, changing the sines and cosines, changing them to secants and cosecants, and multiplying by the reciprocal a couple of times made this problem work out. Okay, you'll notice I have the same problem up here a second time because I do want to show you something that we term advanced factoring. So I'm going to start out the same way. I'm going to rewrite the left-hand side as cosine squared over sine squared, changing my cotangent minus 1, and cosine squared over sine squared plus 1. Okay, so again, something that I'm going to term advanced factoring is I notice up here I have two terms separated by subtraction. I don't want to get two terms separated by subtraction. I have two terms separated by addition, two terms separated by addition, and one fraction bar. So we basically have the same format, just different terms, obviously. So I'm going to try and take a manipulation here and change this to become this. I notice that, or know in the back of my mind up here, that cosecant squared is 1 over sine squared. Well, right here I have the sine squared in my denominator. I just want to remove that cosine squared, so I'm going to factor a cosine squared out of that top term. The first term is pretty easy. When I factor it out, I have 1 over sine squared. Maybe 1 over, there we go, sine squared. Now typically when we factor something out, we can see it in both terms. Well, in this case, I don't see a cosine squared in here, but when I factor something out, I'm essentially dividing by it. So when I divide 1 by cosine squared, I have 1 over cosine squared. So I've factored a cosine squared out of both terms, and then we should notice that 1 over sine squared is cosecant squared, and 1 over cosine squared is secant squared. Going back down to here, if I were to multiply this back together, I'd get back to here just in a different format. So cosine squared times this will get me this cosine squared over sine squared, cosine squared times my second fraction. The cosine squared would cancel. I'd be left with 1. So same value, just in a different form. But in order for this to work, in my denominator, I'm going to have to get this cosine squared here to cancel out. So I'm going to factor a cosine squared out of my denominator as well. And that will leave me with 1 over sine squared here, which is the cosecant squared I want up here. And when I factor something out, I'm dividing. So 1 divided by cosine squared is just that. Again, notice if I multiply these back together, I do get back to this right here. Just writing in a different form here. But now, between numerator and denominator, this cosine squared will cancel. And up here, we'll have our cosecant squared minus our secant squared over our cosecant squared plus secant squared. So two ways, and as I said before, there's more than one way to do most problems. This is something called advanced factoring, so hopefully that makes sense to some of us. Some of us might be able to use that, others might have to go the step-by-step format, but there are different ways to work each problem. We'll go ahead and take a look at another one here. Let's go with the sine of negative x over 1 minus a cosine of negative x minus 1 plus cosine x over sine of negative x is going to equal 0. So as we get started here, you're going to want to probably, at least I would start by working with our opposite angle identities. So sine of negative x is negative sine x. Remembering that the cosine of negative x just basically drops that negative sign out of there, so it stays as 1 minus cosine x. And the 1 plus cosine x here, and sine of negative x is negative sine x. But I would prefer, I think most of us would agree, to work as few of operations as possible. So notice that we have a minus sign here and a negative sign here. When I subtract a negative fraction, I'm essentially adding. So I'm just going to change that. So I have negative sine x over 1 minus cosine x, and we'll change that to plus 1 plus cosine x over sine x. Okay, so again, just took those two negative signs and made it a plus, and this is a 1 here. From here, we're trying to get to 0, so I want to combine these two fractions into 1. So I'm going to find a common denominator, sine times 1 minus cosine. I think I've mentioned this before, but in case I haven't, if you have two separate terms as your common denominator and they're two separate functions, I would leave those in factored form as opposed to multiplying that out to make it two separate terms. So leave it as two separate factors as opposed to multiplying that out with your distributive property. If we go ahead and multiply sine times negative sine, it's going to be negative sine squared. So negative sine squared. I'm going to go ahead and write this out. The 1 plus cosine that's in our numerator needs to be multiplied by the 1 minus cosine that is in the denominator. So when I multiply that out with a FOIL process, they are conjugates, so it's 1 minus cosine squared. I did skip over the outer and the inner terms, hoping we all have become accustomed to that. Remember that from our Algebra 2 stuff, but I'll write it back here. These are two binomials, so we FOILed. But I noticed they were conjugates, same two terms, opposite operations in between. So when I multiply conjugates, the outer and the inner are going to cancel each other out. So I just did the first and the last. 1 times 1 to be 1, and cosine times negative cosine to be minus cosine squared. Okay, so hopefully we're all on board there. Now I notice, or at least I hope I know you notice, that 1 minus cosine squared here in the end is the same thing as sine squared, and over our common denominator. If we look closely then, our numerator negative sine squared plus sine squared is going to be 0, and 0 divided by anything is 0. Okay, so several opposite angle identities get us started there. Some algebra work here with our common denominators and our FOILing process. One identity to know, if we knew 1 minus cosine squared equals sine squared, was a fairly straightforward problem. We'll go ahead and do one more here just to get us thinking along these lines. 1 plus 3 cosine minus 4 cosine squared over sine squared is going to equal 1 plus 4 cosine over 1 plus cosine. Oh, looking at this, my first logical step, see a couple of different ways to start, but I notice my right-hand side is all in terms of cosines, so I'm going to go ahead and change sine squared to be in terms of cosines. So my 1 plus 3 cosine minus 4 cosine squared will stay. Sine squared is a Pythagorean identity equals 1 minus cosine squared. So now my entire function is in terms of cosines. Taking a closer look, my numerator has 1, 2, 3 terms, so it's a trinomial. So I'm going to factor it, essentially reversing the FOIL process. So reversing the FOIL process, to get 1, I can multiply 1 times 1. So the first term of each of my binomials is 1. To get 4 cosine squared, I actually have two choices. I can take 2 cosine times 2 cosine, or I can take 4 cosine times 1 cosine. So with those two choices in mind, I want to have a positive 3 in the middle. When I add 2 and 2 in any combination, I can't get 3, so I want to use the 4 and the 1. So 4 cosine and 1 cosine are the second factors here. Notice I want a negative sign for this product, which means I have to have opposite operations here. Also noting that in my outer and inner, when I add those together, I want a positive 3. So that's going to tell me I want my 4 to be positive and my 1 to be negative. Last term's 4 cosine times negative 1 cosine is going to be negative 4 cosine squared. Outer terms, negative 1 cosine, plus our inner terms, 4 cosine is going to be our positive 3. So we have factored our trinomial by reversing the FOIL process. Since I factored that, I take a closer look at my denominator. That's the difference of 2 squares. So I'll factor that as 1 minus cosine times 1 plus cosine. So we saw 2 of our 3 factoring techniques there. Difference of 2 squares in our denominator, factor the trinomial in our numerator. Between numerator and denominator, hopefully we recognize the 1 minus cosines will cancel, and we're left with 1 plus 4 cosine over 1 plus cosine, which is what we were trying to get to back up here. Okay, so a couple 3 problems just to get us started here. Hopefully that helps out a little bit with some steps, and we have some work that we can do here shortly.